Okay, we are up to 1-3. 1-3 only has one day. So the fancy word they're throwing at us today is piecewise defined functions. Now, I'm going to make this make sense a little bit at a time, but it's also going to challenge your ability to graph. Now, it's graphing with a little twist in the domains. So that's part of the reason why they're calling it piecewise. But there's another layer to that, and I'll get to it. I want to start with just your basic understanding here. This is your good old y equals mx plus b. Notice it's the same thing as this. I just want to bring your attention to this, build your confidence. Remember, this is my y-intercept. So I go up 5, 1, 2, 3, 4, 5. And then my slope is up 2, right 1. You guys have been doing this for a long time. Now, that's my graph if there's no limitations on the domain. In other words, it goes this way forever on the x. It goes this way forever in the negative x direction. And so the domain of this graph will be negative infinity all the way to positive infinity if you remember that discussion. All right, so that's my big picture talk on a simple graph there. Now what are they doing here? Well, what they're doing is they're saying, hey, stop the graph when x is -6. So what I'm going to do is I'm going to take a look at this and I'm going to plug in -6. That's the furthest left boundary they're saying to be concerned about. And then the farthest right boundary is -2. And I'm just going to plug these in. Remember, all you need minimally is 2 points to graph a line. So that's what I'm going to do. So if I put -6 in for here, I get -12 plus 5 is -7. There's my first point. If I plug in -2, I get 2 times -2 is -4, plus 5 is 1. Now I'm going to plot these 2 points, -6, -7, 1, 2, 3, 4, 5, 6. So right here, there's my -6. 1, 2, 3, 4, 5, 6, 7. There's my -7. So where these guys collide, there's my first point. Notice I filled it in completely because it does include -6. So I filled it in as a filled in dot. Pay attention to that. -2, 1 would be -2, 1. That's also filled in because x can be less than or equal to, including -2. Now remember, we worked hard at talking about it being written like this, and they mean the same thing. So there is the portion of the line that they want. So that's the piece that they're concerned about. Now, I wanted to make this green, but I didn't. So let's just remember that this is my f of x. And now let's move on to g of x. So we look at g of x. I'm going to erase this work right here. G of x, I'm going to handle this just a little bit differently. I'm going to look at this, and I'm going to go back to what we've been learning with the parent function, y equals x squared. Now I'm going to make this dotted, like this. It's very generic. It's not perfect at all. But what I'm going to do is, I'm going to look at this and say, what shifts need to happen? Well, if you remember, that's going to move it down 7. 1, 2, 3, 5, 7. Right there. So I know the vertex of the parabola moves right down here. This is going to actually, it's going to stretch it, which means it's going to go up faster, which means it's going to be narrower. And so there's where I'm getting started right there. So I know it's going to be some variation of that. I'm going to get rid of this, and kind of build on this. Once again, I'm going to take advantage of these points, the outer limit, that's all they want. The window, they want the x window to start at -2, so I'm going to plug that one in. And the farthest right is 1. I'm going to plug these in. So -2 squared is 4, times 2 is 8, 8 minus 7 is 1. Now I'm going to plug in the 1. 1 squared is 1, times 2 is 2, 2 minus 7 is -5. So I have -2, 1. Now notice, for this one, if x is greater than. So for this one, it's going to come up like this and go through there. That's going to be an open circle for that one. And then this one, 1, -5, I go 1, and -5 would be right here, and that's all they want for that side of the parabola. Okay, see, we're piecing this together. Okay, so now number 3, we got another one, and we need to think about this. We look at it, we say, okay, what is it? Well, they rearranged it on you. You got to get used to this. This is no different than this. It's just been rearranged. Remember, y equals mx plus b. That just jumps out at you. First thing we're going to do with this, we're going to rearrange it. H of x equals negative. I'm going to put a 1 in front of it. It's going to help you determine slope, -4. See, now I can see y equals mx plus b. So what I'm going to do is I'm going to just go ahead and cheat a little bit and say, okay, they want my x to start at 1. Remember, it includes it. And it also wants to end when it's 3. So I'm going to go ahead and plug these in. Now, I didn't have to rearrange it, but I just wanted to help you understand that it's a line. So I put 1 in for here. 1 times -1 is -1, -4 is -5. Put a 3 in. 3 times -1 is -3, -4 is -7. So here's my first coordinate point, 1, -5. Notice that is filled in. So that's a filled in mark right there. And then 3, -7, 1, 2, 3, would be all the way down here to -7 right here. And that is also less than or equal to, so I fill it in, and then that's just a line. Okay, so really what we have is f of x here, we have g of x here, and then we've got h of x here. So here we have 3 separate problems, but I just put them on the same graph. Guess what? The math problems are going to be presented to you like this. So they're saying this one function is going to represent this plus this plus this. Notice all 3 of these things are the same as these 3 things. They're just stuffed into one problem because of this fancy little teacher thingy. So they're saying, hey, f of x equals this, graph it with this limitation. F of x equals this with this limitation. F of x equals this with this limitation. It's one graph, even though there's 3 completely different components to it. This is unique. And then it ends up looking like this. This is going to be your answer. Now, what they're going to do then is they're going to ask you questions about your finished product. And they're going to ask you like, all right, what's the domain of this entire thing? Well, the furthest left point is -6, and it's a bracket because it's included. Remember that? Furthest right point, I forgot what that was. Yeah, it's 3 to the right. So 1, 2, 3, down 7, but we're talking domain, so it's 3 to the right. And it is a filled-in dot. You can easily make a mistake there. Now, what about the range of this function? Well, what's the lowest point? The lowest point is right here, -7. It happens twice, but we only have to list it once. What's the highest point? It's right there, 1. And it was filled in for 1, and it wasn't for the other, but because it's filled in once, we're going to put a bracket on that. And there's the range. Now let me hit pause a second. Okay, the final thing they might ask you about is what's the rate of change of the interval? Now the interval means the entire finished product. What's the rate of change? Well, that means you go from the outer extremity, which is -6, -7, and then you go to the furthest right. Now that point on a different graph could be up here, could be over here. But that point right there is 3, -7. So as you can see, this thing, I mean, you can just use your common sense and say there is no rate of change. It's 0. Now, if you wanted to get fancy, you could call this x1, y1, because that's our beginning point. This is x2, y2, because that's our finishing point. Using the formula, y sub 2, I'll use it over here. Y sub 2, whoops, negative 7, minus a negative 7, all over x sub 2, minus x sub 1, that would equal negative 7 plus 7, which is 0. 3 plus 6 is 9. It doesn't really matter what that is down there. 0 divided by anything is 0. But we could have just looked at that and said it's flat. So there is no rate of change. Remember, rate of change is just a phrase for slope. I think that'll do it. All right, next thing we're going to do is take a look at a few sample problems, and then the homework should make sense.